By late May, millions of people across North India are living in a furnace. The temperature gauge stalls out past 45 degrees Celsius, peaking at a lethal 48 degrees in parts of Rajasthan. There has been zero relief since early May. A stagnant, high-pressure system has trapped the entire northern half of the subcontinent in a massive heat dome, baking the earth dry. This forecast map for May 28th lays out the battlefield. It marks the final day of extreme suffering for many of these regions before a massive atmospheric shift takes over. Relief is finally on the horizon, but the break in this heat wave will be a violent, high-energy collision. Meteorologists call the incoming catalyst a Western Disturbance, an active, highly energized front packed with moisture, and it is about to crash head-on into that stationary wall of hot air. The sheer amount of energy stored in a 48-degree atmosphere is immense. When it meets a sudden moisture front, that energy is released through a sequence of severe weather events moving across the map. The collision officially begins on the afternoon of May 28th, striking the highest elevations first, the peaks of Jammu and Kashmir, Himachal Pradesh, and Uttarakhand. The moment that incoming moisture hits the freezing upper atmosphere, the weather snaps. The collision immediately triggers moderate thunderstorms, sudden snowfall, and intense high-altitude hail. By late afternoon and into the evening, the system physically rolls down out of the Himalayas, spilling into the lower foothills and the vast flat plains of Punjab, Haryana, and Delhi NCR. Here is where the thermal physics take over. The heavy, moisture-laden cold air drops out of the mountains and acts like a wedge. It slides underneath the superheated surface air that has been baking at 45 degrees, forcing it violently and rapidly upward. That extreme upward thrust provides instant fuel. It rips moisture into the sky, creating towering, highly volatile thunderclouds directly over the plains. But before a single drop of rain hits the ground, that atmospheric instability creates chaos. It whips up severe, blinding dust storms that sweep through the major urban centers, turning the sky a suffocating brown. Your immediate threat depends entirely on your altitude. Up in the mountains, you absorb the direct moisture and the freeze. Down in the plains, you absorb the violent kinetic energy of the temperature clash. As the timeline pushes deep into the night, the front crawls further east and south, slipping into Bundelkhand, southern Purvanchal, and northeastern Madhya Pradesh. The people living here experience a sharp contrast. They bake under clear, blistering skies for the entire day, only to be hit by gale-force winds and torrential rain long after the sun goes down. But look closely at the solid blue and white zones on this forecast map. These are the holdouts, the regions that remain completely untouched by the Western Disturbance on May 28th. Zooming in on central and west Rajasthan, as well as western Madhya Pradesh, the data shows they are firmly trapped. The cooling front hasn't reached them, leaving them locked under the worst of the 48-degree heat dome. The reality on the ground here is grueling. While the rest of northern India floods, residents in these deeply arid zones must endure another 24 to 48 hours of life-threatening heat. The slow pace of the front creates a fractured weather map. One region battles midnight floods, while just across the state line, the heat dome remains firmly in place. By May 29th, the Western Disturbance expands its footprint, dragging a blanket of severe weather across the majority of the northern plains. This expansion brings the first real break in the heat. Widespread thunderstorms finally wash the dust out of the air and drag temperatures down to survivable levels in major cities like Delhi. Finally, on May 30th, the system makes its last push, marching into the most stubborn holds of the heat wave down in south and west Rajasthan. The arrival of rain in the deep desert is meteorologically final. It physically breaks the high-pressure system, causing the heat dome that terrorized the country for an entire month to collapse. Over 3 days, this weather system journeys from a high-altitude crash in the freezing Himalayas to a final rain shower in the scorching western desert. Breaking a subcontinent-spanning heat wave is a violent sequential domino effect, a sprawling clash of physics that forces us to track exactly when and where the atmosphere will strike next.